All right. Hello, everyone. I'm super excited to be here. I've been here 5 years ago. It was, I guess, my second public speaking ever, and I was freaking out. Not that it's any different now, but I hope you guys gonna stay with me till lunch. I hope you are not that hungry and you're gonna stay focused despite of the party yesterday. So the topic of my talk today is Dockerized system testing with a dash of chaos. Which on the agenda is assertable chaos monkeys, but that's pretty much the same. So what I will gonna show you today, and I hope you're gonna have quite a bit of interesting thoughts after you leave, is how we can make testing better and how we can leverage Docker so that you will be not struggling a lot when writing something higher than unit tests. But before we dive into technical details, let's step back for a second and agree on one simple fact, that software is everywhere. Software is not only on our computers and our handheld devices, software is in our kitchen, in our living room. It's actually also just about to start driving our cars. And most of it, if not all of it, is written by us, developers. And we, as human beings, tend to make mistakes. To quote one of the, I would say, most important computer scientists from the previous century, Edgar Dijkstra, is that if debugging is a process of removing software bugs, then programming must be a process of putting them in. So what can we do in order to prevent bugs sneaking into our code and making our lives miserable? One of the tools we have are automated tests. But before we dive into automated tests, let's talk about some bugs which happened not so long ago. So first one, which is quite scary, is the bug which happened for Tesla S model. They figured that when you drive on the highway and the clearance of your car is too low, you can literally set your car on fire. So what they did, they sent a patch over the network, and just by improving software, they fix it. So it wasn't, I mean, now they have a bit of a different problems with self-driving cars, but let's skip it. Another one is kind of a stressful one, I would say. That happened in Orly in Paris. It's one of the airports they have. They have a system for monitoring weather conditions, and somehow, for a reason which I cannot explain, in 2015 it was running on Windows 3.1. And what happened is that it just stopped working. So the control tower couldn't really monitor and inform pilots about the weather conditions, and it took them, I guess, 3 days to find a person who could fix it. Because in their area there were like 3 guys, and 2 of them were on holidays at that time. And then there's another category of bugs which are, for us end users, annoying. In this case, for the vendor, let's call it this way, it was quite satisfying. This happened to the Swiss guy playing in casino in Austria. He won $57 million, but casino said, oh, sorry, that's a software bug, and we cannot give you this money. What we can offer you instead is $100 and voucher for free lunch. So again, what we can do as developers to make our life easier and to prevent from such a strange situation happening is, as I said at the beginning, we can use automated tests. And if we think about automation and automated tests in particular, the first thing which comes to mind, these are unit tests. And this is a great tool because it gives you the fastest possible feedback about how your components are working and if your assumptions are correct. But it's also a great design tool, because you, as a first consumer of your service, of your API, have a great chance to think not how to expose your implementation afterwards, but how you can actually construct your components so that they will be not only easy to use, but they will be also easy to understand. So that's great. We learn about unit testing. We learn about all the test doubles like stubs and mocks. The problem is that most of the people, at least with whom I worked with, when they learn about mocks, they pretty much mock everything. So what you have at the end of the day is a test which has 10 lines of mock definitions, expectations, then 2 lines of verification, and then some cleanup code. The problem with it is that this is not really a usage of mocks as it should be intended to, because when you use mocks, you should think about if it's the interaction you do, if it's a query, or maybe it's a command, is it an inbound operation or outbound? So maybe you should verify the state, or maybe you should verify behavior, but in a lot of cases I've seen, you end up with a mockery or a tests which are actually change detection tests. Because the code in the test is pretty much a duplication of what you have in your component under test. And then whenever you change something, all falls apart, everything is red, which kind of contradicts with TDD flow, because TDD flow is red-green refactor, whereas refactoring is changing the internal structure without changing the overall behavior. So one of the solutions here, besides using the mocks correctly, is to use so-called social tests. And social tests are still unit tests. The difference is that you don't mock all the immediate dependencies. You construct them and you verify a bit broader flow of data or broader interaction. Here the problem again is that you might end up with quite excessive code for wiring them, and they don't really give you still a full picture, because the ultimate question you have before you push your code to production is, will it ever work? Am I sure that the stuff I'm just about to deploy will work properly? Or maybe you will get a 2 a.m. call from your angry boss and you will be requested to fix it. So next to unit tests, what I believe we should also have in place are high-level which run in the production-like environment. And I'm not only saying here about integration tests, I also mean here UI tests, performance tests, and so on. But with those higher-level tests, we need to ask ourselves why people don't write them. Why is it perceived as something which is waste, which is not really giving you that much of a benefit? And there are several reasons for that, and I would like to walk over 4 of them, which I find important, and try to show you solutions which will make your life easier. So first thing is that it's quite hard to wire all these things. It's quite challenging to set up all the moving parts, all the environment you get involved in, because it's not a unit test anymore. You have, let's say, database, you have some message queue, you have whatever your service is using, and this, in most cases, might require quite a bit of a bootstrap code and quite a bit of wiring altogether. If you use Spring, then they have a Spring integration test framework, which is pretty handy. What I would like to show you is Arquillian, which has a bit broader use, even though it was born for CDI spec, but the tool itself is useful way beyond old and boring Java EE. So how many of you have heard about Arquillian? Okay, let's say a dozen. And who is using it? Oh, just one person. Okay, so after that, I hope everyone will be. Okay, so going back to the problem. So Arquillian is not yet another testing framework. What I like to call it is that it's a testing middleware. So it takes care of all the heavy lifting, all the plumbing of your environment components, let's call them this way, so that you can actually focus on writing the tests as it intended to be. You don't bother about all embedded servers, all the database, and so on. The test itself, at the moment you write it, it looks and feels like regular unit tests. So the goal is to fill the gap between writing a unit test, which is a pure pleasure, to the integration test and beyond. As I said, it's started as a Java EE framework, testing framework, but it's way beyond that. We support not only integration testing, not only in container testing, we also support UI tests, we also support black box testing, which I will show you in the demo. And the most important thing, it's open source. It's free. You can take it, you can use it, you can contribute if you have time, you can tell us what we should improve, and so on. So let's have a look at the sample test. but before we do it, let's see how we should actually bring it into our project. I use Gradle because Maven won't fit in the slide, so that's one of the reasons. And also, I think Gradle is way more pleasant to work with. You need to bring the bill of material dependency, which defines all the other things you might want to use. And then simply grab the integration with your test framework of choice. In this case, we can grab JUnit. We also have support for TestNG. We have support for Spock. We do have support for Cucumber and probably some other which are not in the official ecosystem, but I know that there are some others which are provided by the community. And then you can define your container of choice. Let it be Tommy. You can use Whitefly. You can use WebLogic, God forbid, or WebSphere. And then the test itself is pretty much almost as easy as a unit test. So here, in this example, I do have a REST resource which converts fluid ounces to milliliters, which for those of you who travel to America might be quite handy, because I always have problems wondering if 8 fluid ounces is enough with their crazy heavy beers, but actually it's not. And in the test itself, what I'm using is REST assured. If you haven't heard about REST assured, give it a try. It's very nice DSL, BDD-oriented HTTP client, let's call it this way, which lets you exercise your resources in the black box manner. So here what we have is we provide some base URI, then we call get on our resource, and we can inspect the response. So far so good. The problem is that we assume everything is up and running. We hard code or provide by some environment properties the URL, but I think we can do better. So with Arquillian, test is a bit bigger, but there are only two extra things you have to add, and then the rest is just almost the same logic as we have seen before. So first and foremost, you use the custom runner from JUnit. If you use TestNG, then you extend the TestNG runner. If you use Spock, then we have a special specification extension. Then you define the deployment method. So this will be something you will deploy to your container of choice. You can use shrink wrap, as I'm using here in this given example, where you pretty much use Fluent DSL to construct your deployment unit. You don't have to. You can actually just grab your build jar or war file and just put it in the deployment method itself. The interesting thing here is that when you use shrink wrap, you have also a chance to think if your module is small enough. Because if you will end up writing very long deployment method, then something might be wrong. It might be a good chance to split it and think about smaller contexts. And then, as it's a black box test and we exercise it from outside the container, I also can mark that it's that the deployment itself won't contain any Arquillian logic. So okay, let's have a look at the demo. So I think that's this guy. So I will just run it quickly. So the first test I have is running in the container. So I will exercise my CDI bin. That will be the only slide with Java EE, I promise you. So let's quickly run it. So what you will see happening is that I start Whitefly underneath. I deploy my war, and from within the container, I inject my converter bin, and I just exercise it as like in the regular unit tests. On the other hand, the example I showed in the slide does it a bit differently. I also deploy my service, but what I do, I exercise it from the outside. So you can use the same technique to test your REST resources or the UI. So as simple as that. Each and every test was reasonably fast, I would say, and you don't need to take care of any heavy lifting for your application server or any other technology of choice you have in place. Okay, any questions so far? All right, so let's have a look at another challenge we face when we write tests which go beyond the unit, beyond the isolation. Okay. Oh yeah. Something went wrong with my Flickr. Sorry about that. So what are the principles of Arquillian? So if you recall the test, there was no notion about the target environment. The only thing we had was the deployment and our test. All the other stuff was hidden. So the tests are portable. If you have another environment, let it be with embedded database, embedded server, or anything else of your choice, you don't need to change any test logic. You just need to change a bit of the configuration and probably provide another jar, which is an adapter, which takes care of all the heavy lifting. Another thing is that you have the same experience like with unit tests. You can directly run it from the IDE, and it works seamlessly. You can also run it from the build tool of your choice, and there is no difference. The thing which I highlighted about the string grab, the main advantage here, besides that you can construct your modules granular enough, is that you can skip the build. So you don't need to run the whole build of the application, which in not hello worldish example like we have seen here might take more than a few seconds, but you can also leverage incremental compilation of your IDE. So that's another benefit in my eyes. Then we don't reinvent the wheel. We provide, as I said, the middleware. And all the other things we just take best of breed or the most popular things people want to use. So we have JUnit, we have Spoke, we have TestNG, and a bunch of other things. It's flexible and extensible, which means that back in the days when it was created, there were not so many things besides application servers which it was supporting, but the model based on the SPIs is powerful enough that now we can provide support for controlling Docker, for simplifying usage of simplifying usage of WebDriver, and so on and so forth. And at the end of the day, the extensions are fairly slim. You just provide a bunch of APIs and you implementations for the APIs, and you just hook into the event model, which effectively what Arquillian middleware is just an event machine. And then hopefully you got convinced a bit. It makes writing high-level tests a breeze. It's almost as easy as with unit tests. So another problem people have is that integration tests and above, they are not repeatable. You just run your build, it works. You run it the second time, it doesn't, even though it was fine locally. It could be that the port was taken, it could be that JBoss or any other piece of technology you use had some leftovers. And we just rerun it again, maybe it works, maybe not. It's pretty much insanity. To quote Albert Einstein, doing the same thing over and over again and expecting different results is insanity. So we should build our testing environments in the way that they will be repeatable. And for that, obviously, we can use Docker. How many of you know Docker by now? It's been 3 years since it's around, so quite a bit. Okay, cool. But for those of you who are fairly new with the concept, so Docker, some people say it's a lightweight VM, which is not entirely true because it's not VM in the sense of virtualizing the hardware and other layers of operating system. You can think about it more like an isolated sandboxed process. So it runs on your Linux machine or now even on Windows, but as long as you don't define access to the host system, it's just self-contained. So you have a client which might be a Docker CLI, which over the REST API, it talks with the daemon, and daemon takes care of bringing the images, which are definitions of your containers or your sandbox environments, and out of images, you can spawn the containers. And the cool thing about it is that the container itself is immutable. So you can run as many as you want, and as soon as you kill them and you rerun them again, you start from the same state. So especially in testing, it's very important to have such an environment. I mean, obviously, it's also important when we go to the cloud and we build distributed services, But for testing, the technology is super handy, and I think it's a very good way of introducing Docker to your company. When you start using it as a developer, you give it a try, you see all the benefits, and then maybe you will also see a fit in your environment of your projects. Okay, so in Arquillian we have extension for that. It's called Cube, and Cube pretty much does all the control over Docker. So it will take care of the life cycle, so it will pull the image if you don't have one locally, it will start it for your tests, it will execute the tests against it, and then it will clean it up. So again, you can just run it straight from the IDE, as we have seen in the first example. Then we also orchestrate the containers. Nowadays, you can use Docker Compose for that. We started with this extension before. We came up with the YAML, which is quite similar. Then, if you want to use, or if you want to interact with Docker containers from your tests, we also provide something which we call container objects. You might think about it like page objects for WebDriver. So we just encapsulate the behavior or the low-level interaction with Docker and give you a way of constructing some higher-level API so you can control your containers also straight from the tests. It supports anything which is actually Dockerized. It doesn't have to be app server. It can be Node.js. It can be any other kind of application you would like to write your tests against. It works on OpenShift. So it also works with Kubernetes underneath, and we support Docker machine as well. So again, just a small slide with Gradle. Just bring one dependency with the latest version, and then you can configure it if you really have to. It's not required if you don't use Docker machine. That's not necessary. If you just use Docker Compose, that's probably also not needed anymore. If you use Tomcat or any other application container, you might want to configure it, but that would happen also for the simplified setup when you don't involve Docker at all. It's just a way of getting into the container itself. Docker and Compose, no magic, just define two services, for example. You define from which image you want to pull them, you link them, you expose the port. No rocket science, no addition from Arquillian, no magic. Then the test itself, again, fairly similar. We use the runner for JUnit. We deploy our war, in this case, which is just a Hello World application. What we get from Cube is that we don't need to hard code the host IP, which in case of Docker machine might be handy. And also we can inject the port, which here says, give me the port which is visible to my host, but within the Docker container it's defined on this value. Or we can do even easier, you just get the URL of your application which you deployed. That also can work easily. And again, the test is quite portable and there is no hard dependency on your environment as such. So, as I said, I won't show you the Java EE containers anymore. Let's talk about containerless, which is a bit unfortunate name. But what we mean by that is something which is not Dockerized application server. If you guys have a better name, we are open for suggestions because this is super confusing. But this is how the tool is called right now, so that's why I use this one. So this is part of the cube which fits any kind of application which is Dockerized. So we can test Node.js, which we will see in the example I will show you in a second. We support Whitefly Swarm, for example, Spring Boot, Vertex, Go services. If you want to test your Go services using REST Assured, for example, you are free to do it. We are all polyglot by now, so why not? We do have a shrink wrap support. So this is this Fluent API I was showing. This will help us leverage Docker files. And you just need one simple dependency for that. And then that's the test. So what's happening here is I'm creating some simple JavaScript application. So I pull in two files in this case, so my app and the dependencies. Again, the same mechanism as for the previous example where we were bundling war file. And then there is no notion of Docker. We will just provide a Docker file, and we can run our tests. So the Docker file looks like this. It's not exactly a Docker file as such. It's something which we will create on the fly because we depend on the file name which we're going to add to the container. But other than that, it's pretty much the same as you would probably use for your Node application. So let's see it in action. So I have a very simple app, which is again the REST endpoint, crawls for the strongest beer in the world, which is 67.5%. Checked it yesterday, it's still the strongest one. It's Express.js. My test, since I'm a Java dinosaur, I wrote in REST assured. Probably JavaScript, Node.js guys would leave the room now. I guess few people did. And then the next thing is the Dockerfile template, which will pretty much be alternated on the fly when we run the test. So I will run the test. In the terminal here, I'm watching the Docker containers which are executed, and we will see that some stuff is happening. So you see now it's starting up. You will see two containers. Now the first one is actually running, or was running, npm install, because that was the part of our Docker file. So it pulled in the whole internet, and now we have the test against the real one. As you have seen, reasonably fast, say super fast. We took care of all the plumbing. You have just the test with a Docker file, and that's it. And this is very helpful when you want to have a repeatable environment which you have a full control over. You can test against different whiteflies, for example, or different versions of Node, maybe. All right. The third issue people have, and this will be not really about Arquillian, is that the integration tests and above, they are freaking slow. Which is true, because unit tests is just a simple jar with nothing else than objects, whereas when we go higher than that, we employ a lot of moving parts, and those things take time to bootstrap. So even if you run Spring test, it takes a second or two to spawn the embedded Jetty, for example. So I have one project which is a part of our Arquillian ecosystem, which takes care of controlling the database, and I need to test it against different versions of MySQL, Postgres, different application servers, and each and every run for given configuration takes at least 3.5 minutes. Other problems you might have is that your huge set of UI tests, for example, takes enormous amount of time. So what you can do, you can group them, and you can run the groups in parallel. I mean, you can try to do it with build tool, but then you might hit some bugs, like in Surefire. But since we have now Docker, we can easily use it for isolating the builds and run them in parallel way easier and in way bigger control than with regular builds. So with my project, when I had, let's say, 3 application servers, so Whitefly 8.1, 8.2, and 9.0, and Postgres, I would need to spend at least 10 minutes if I run them sequentially. So what I came up with is I run the builds in the containers, but I also run more than one at the same time. The problem here is that if I don't want to change my configuration of the tests, I still might rely on the default ports. So like Whitefly is probably 8080, Postgres is 5432 or something like that. But this is also very easily solvable using Docker, because Docker has isolated networks. So what you can do in Docker, you can define your own network, define the containers which belong to it, and another network with similar containers, but they are not aware of each other. So let's see how it looks in action. So I run the build. You see in parallel, it runs 3 different builds. You see here, I already have 2 networks. Now is the 3rd one which started. I have 3 containers with Maven, so I copy my whole project to each and every container, and within it, I also have access to Whitefly and Postgres, and they're pretty much the same ports, but they are not exposed. They can be run in parallel. The only disadvantage of it is that at least my CPU goes to 85 degrees. But other than that, I run them all at once, and it takes 3.5 minutes to have feedback for all of them. And you can do the same technique with your tests. If you can slice your UI test, for example, to different groups, you can try to Dockerize or use a Selenium Firefox Docker container with your application server, for example, then use Maven or Gradle container, put them in one isolated network, and run it. Maybe not locally, maybe better for your build server, but something which you should consider because it's enormous gain of time. And it's under your full control. You don't mess around with external things. You don't have to install any artifacts like like MySQL version 5.4. You just pull the image and run it in entire isolation. Okay, and the last issue people have with high-level tests is that they consider it a waste, which is to a great extent true, because what I have seen also from Arquillian community, people get Arquillian, they are excited about it, and all of a sudden they test all the possible flows of their components, let's say CDI, using Arquillian, which is not necessarily what you should do, because this stuff you can easily test in unit tests. What you can do with Arquillian is just to pick one, let's call it a user journey or some happy path, and just check if all the things are interacting with each other correctly. But also, higher level tests can be used for some different purposes which unit tests cannot give you. And this is for controlling tricky situation or chaos. Any Star Trek fan in the audience? No one. So Q is a guy who, when he shows up in Star Trek, it's just total chaos. It's just a disaster. So that's why we named this extension Cube Q. And we provide several scary things which you can do with your services. So, for example, we can introduce container chaos. So if you have your services Dockerized, we can throw in some additional container which will randomly stop, kill, or even remove the containers. So you can see how your application tolerates the faults. The other thing we can do, we can, using a Simian army from Netflix, we can just randomly mess around with the operating system. So we can block ports, we can set your laptop on fire, we can fill in the disk, and so on. Or maybe something with, which might be interesting for end-user experience is that we can control the network. So we can manipulate the latency, we can play with the bandwidth, we can kill one of the services for a given amount of time, or we can introduce some timeouts. So in this way, you can easily verify if your fault-tolerant logic will work before you actually hit the production. And in terms of the network chaos, it's fairly simple. If we have 3 services which are linked to each other, what we do underneath, we throw in toxic proxy, which will serve as a hidden proxy between the service we are exercising under test and those 3. And by using simple DSL, we can just do some chaotic things on it. So if you have Docker Compose, you don't add anything to it. It's just the same definition of services that you probably would use in production. Maybe not the hello world, but I guess you get the concept. And dependency, fairly simple, just one, Cube Q toxic. And then the test itself, we use the runner, and we can inject the resource. We have plethora of resources. In this case, we can inject something which we call a network chaos, and then we can say, on our ping pong service, we introduce a latency of 4 seconds, and this block will be executed when this happened. So, last demo for today. So far, I don't have any hiccups except of slides which were not flipping. So let's hope this will work the same way. So here, what I have is, it's not really a test per se, but it just demonstrates what will happen with the service under which we interact with. So the first block is just a regular interaction. We just call hello world. This will call the ping pong service, and it will return the response. Second block means that during 15 seconds, we again gonna do the regular execution, but this time with the proxy involved. The third one will introduce the latency of half a second, so it will get slower a bit, and the last one will just take the service down. So let's have a look how it works. So I started underneath Cube controls all the Docker containers I have defined. So we have the ping pong, we have the toxi proxy, which will be used seamlessly, and the ping pong, which we're gonna toxify. And as extra, I also brought in the Hystrix dashboard because I have a Hystrix command for my Hello World service, so I can see how it will behave. Okay, so I continue with the test. And you see in Hystrix, everything is good so far, everything green, requests are flying by. But at some point, it will get slowed down because we introduced the latency, which probably this graph is already somehow hinting. Yeah, so it's getting slower. And now at the end, it will just throw in red and just stop working, and the circuit will be open. Yep. So now we pretty much took the ping pong service, which is the one which our service under test interact with. It's down because toxi proxy just mimic it. Okay, and now the test is finished. We just need to clean up all the leftovers from Docker containers, and we get the green bar. Okay, so let's recap. Let's quickly reflect what I have presented over these last 35 minutes. So first and foremost, my message is that unit tests are super important. If you think about testing pyramid, that's a great start to think about the amount of tests you should have. It shouldn't be a silver bullet because sometimes the risk might be on the integration layer, so probably you might need to have more integration tests, but this is a very good starting point when it comes to setting the focus or telling you what should be a proportion between each and every layer. But the high-level tests which run in production-like environment give you confidence that when you deploy your application, it should work as you want it to. I mean, we are all humans, it might not work, but at least you have a tool which will give you more confidence in shipping the features to production without sweating all the time. When it hurts, automate. So my problem with long builds when I was running one after the other, it's one of the examples. Docker just brings two concepts which are fairly easy to understand, and you can, assuming that you have more than one core on your machine, it should work fairly good. Arquillian is not only a Java tool. You can use it for any other stuff. You can use it for any JVM technology you might want to. But you can also use it for Node.js or any other platform. Be prepared for unexpected. It's very important to test boundary conditions. It's very important to see how your application behaves when some unexpected condition is met. And I'm not saying here you should test for expected exceptions in your unit test, but think about such a machinery which can let you inspect how your application behaves under stress or under some unexpected circumstances, which will happen when you drift to microservices, because you have plethora of interconnected things, and network is not a reliable thing to start with. That was only a tour of 2 extensions for Arquillian. Have a look at what we have more. It's arquillian.org, that's the website. We have also tools for fault injection to your services through bytecode manipulation. If you want to test your repositories with JPA, we have a tool for that. If you want to have a bit less hassle with Selenium or WebDriver, we also provide a tiny little wrapper which controls all of it. And that's it. My name is Bartosz Majsak. I was introduced already. I always try to introduce myself at the end, because content is the king. I hope you liked the presentation. I work in Red Hat. I'm a code monkey. Try Arquillian. Let me know if it's cool enough. You can follow me on Twitter. If you liked my talk, let me know. If you didn't, then please do even more. And this is my GitHub handle, so you can see what I'm hacking around. Thank you. And these are the resources.
Thank you very much.